Hey guys, so I'm currently doing research on a video I'm going to make on the Common Core curriculum, specifically the math portion of it. And I am actually in favor of the Common Core, which I know a lot of parents and students aren't. As a matter of fact, if anything, it's brought up a lot of hostility with people. But I think that Common Core addresses something that I've said for years. And I guess my opinion on math education, it's kind of, I'll say it kind of in an, I guess an analogy, and then I'll say why. So the way I think math is taught, or the way math has traditionally been taught at least, is imagine someone comes up to you in kindergarten and they give you orange this big orange ball, and they say, here's a ball, and then the students are like, well, what is it called? And they're like, don't worry about that. So they tell you to, they just say, hold this ball and walk around with it. And you do that for, from K through first grade. And then in second grade, they say, okay, now what we want you to do is we want you to bounce the ball off the ground, and we want you to hit the ball with your hand and bounce it off the ground. And they're like, okay, but why am I doing that? And they say, don't worry about it. Then the next year, they say, okay, now we want you to do this while walking. Okay, why are we doing this? Don't worry about it. Don't worry about that. And then eventually the next grade, they say, okay, now we want you to figure out how you can, you're walking and you're bouncing the ball. Now we want you to get it where you can run and bounce the ball. Now we want you to get it where you can pass the ball. And you keep doing a little step by step, step by step, step by step. And then all of a sudden, your 12th grade year, they come up to you and they say, after you've learned to dribble the ball, after you learn to dribble and walk with the ball, after you've learned to dribble and run with the ball, they bring you to this big room with lines marked on the ground and these weird rope things hanging from this weird platform. They say, hey guys, that thing you're holding is actually called a basketball, and you use that thing to play a sport called basketball. Bye-bye, right? That's kind of the way math is in a way, because what you do all the way up, even through high school, unless you take calculus, and then maybe you get a hint of what math is, and I'll say why in a second, you really don't learn a lot of what math is. Instead, you learn specific parts of math, and they don't even, it's just shy of even telling you, you don't learn what math is. You don't learn, I guess maybe in geometry you'll learn some proofs, but you don't learn how to construct an argument. You don't know how a proof works. You don't know what an axiom is. And these are the foundations of math: axiom, proofs. So you can take geometry and you may not learn what an axiom is. You may not learn that you can change the axioms and create all new geometry. So what the math curriculum really is designed for is to lead people to the skills they need to do particular computations that are essentially used in calculus. How to work with fractions, decimals, exponents, how to graph. But a lot of the stuff you don't really see unless you stick it out in a rigorous math program, and people won't see what a proof is. They don't know what an argument is. They don't know what a fallacy is. None of these things. And these foundations of reason and logic is what mathematics is. Now, some people may be saying, is it reasonable to expect high schoolers and middle schoolers, whatever, to understand these things? And absolutely, in some ways, it would be easier to teach a sixth grader how to construct an argument than it would be to show them long division. So I think what Common Core was trying to do, or what Common Core is trying to do, because I think there's still a number of states that still use Common Core. I think the majority of states still use Common Core. Is trying to tighten it up, because some people and people I respect who are math education, I kind of agree with them. They think that math is trying to do this very broad, very very broad, miles wide, an inch deep. So if you can teach people how to reason and how to work through problems, then the other stuff, they can actually pick it up even faster, if that makes any sense. So I think a lot of people, well, I'll just say this story and then I'll kind of end the video. The funny thing that happens, that I hear from a lot of students, is when you ask them, and these are, college students, 18, 19-year-olds, usually, and they can even actually be in their 30s and this happens. You can ask them, how do you feel about math? Are you comfortable with math? And the thing that I've heard so many times is, I'm not good at math, but I'm pretty good at geometry. Because in their mind, math is numbers and long division and multiplication and finding x and all this other stuff. But geometry is something separate. And the thing they don't understand is that geometry, in some ways, is a purer form of math than what they were doing when they were learning college algebra. And the other thing that I've noticed is that when I have students who are taking a quantitative reasoning class instead of a college algebra class, some of the stuff that's covered in quantitative reasoning, if you don't take quantitative reasoning, if you're a math major, you're not going to take quantitative reasoning because quantitative reasoning, it's a class for non-STEM majors more times than not. But you're not going to see things that are covered in that class unless you go on to something like a proof or foundations of proof or intro to proof class, such as fallacies in an argument, how to construct an argument, how to see how to determine a bad argument, truth tables, that sort of thing. So these students who are, I guess, by definition, not as strong in mathematics as their STEM counterparts, actually learn math that their counterparts won't learn unless they are kind of some hardcore math students. And in some ways, they're learning more math or actual math, while the other people are just learning how to kind of dribble a ball and walk around and pass it without ever learning what the game of basketball actually is. Anyway, thank you. Hey guys, so in the video I mentioned that if you take calculus, in that case you may see math for the first time, and then I said, well, I'll explain why. In a second, I never did, so I guess I'll do it now very quickly. So if you take calculus, what you're going to see is something called a limit, and the limit uses something called a delta epsilon proof. So because mathematicians are insane, we all of a sudden start using Greek, and we start using Greek letters because we ran out of all the letters from our alphabet. Then after we use all the Greek letters, we start using letters from the Hebrew alphabet. And I'm not even exaggerating because, like I said, mathematicians are insane. The only thing about this is that often calculus teachers won't even bother to show students the delta epsilon definition of the limit, because here's the thing. The delta epsilon limit doesn't use numbers. It uses symbols. And that's what makes it real math, because I'm not saying that numbers aren't math, that would be insane, but the numbers are symbols that are representing other things. And the idea that you're using these symbols to define something in a broad, in a generalized term, because what makes math different than, or mathematics different than physics, is that physics concerns itself with the real world, and mathematics concerns itself with the hypothetical general case. There's a great speech or great talk where Richard Feynman, he says it much better than me because he's Richard Feynman. But that's what math is. It's this generalized form where we use these symbols. And of course, because a lot of these students have never seen just math in that form, in its real form, where all we're using is symbols to represent these general cases, more times than not, students are very, very confused by this proof. And I'm not saying it wouldn't be confusing anyway, but I think because of the way they've been taught math up to that point, it's even that more confusing. All right, this time, thank you. I'm done.